All right, we're finding the limit here. And the first thing we want to try when doing the limit is just using the basic methods like direct substitution. So let's actually check direct substitution and see if it will work here. That means I'm going to be plugging 1 in for x. So it's going to be 1 to the power of 1 over 1 minus 1. Well, that would be 1 to the power of 1 over 0. And in the context of limits here, 1 over 0 equals infinity. So this gave us 1 to the power of infinity, which, yes, is one of our indeterminate powers. And so, yeah, it's going to be a bigger process than just plugging it in and seeing what the answer is, unfortunately. We are going to end up needing to use L'Hopital's rule. So in order to do that, we are going to write the limit of y equals on the other side. Then we will take the natural logarithm of both sides. And we do the logarithm in order to be able to take the exponent down outside of the logarithm and then turn it into a quotient from there. So let's actually go through that process. First thing is we write it as the limit of y equals on the left side now, so we've made it into an equation, and we do that so that we can take the natural logarithm of both sides. And again, the purpose of doing that is being able to pull down this exponent, and that turns it into a product then, which will then later turn into a quotient. And so now that I have my product, in order to turn it into a quotient, I do always want to keep the natural log on top, but it works out really nicely in this case because, of course, this is already a fraction. And so now that I have that written as a quotient on the right-hand side, I can now go ahead and apply L'Hopital's rule by finding the derivative of the numerator and the denominator separately. Oops, we forgot an x up there. There we go. And so first up on the top, I'm going to figure out what's the derivative of the natural log of x. That's nice. We don't even need to use chain rule or anything there. It's just 1 over x. Then that's going to be all over the derivative of 1 minus x. Well, the derivative of the 1, of course, is 0. The derivative of negative x is negative 1. So it's all over negative 1, which I can just clean up a little bit to just write it as negative 1 over x. All right, I'm now at the point where I can try direct substitution again. So I'm going to take the 1 that I'm approaching here, and I'm going to plug that in for x. And so if I do that, I end up getting a negative 1 over 1, which just equals negative 1. All right, yay! There's just one little problem. We're not actually done. Remember, when I did that, I actually just figured out what the limit of natural log of y is approaching. I still need to just know what the limit is of y. And in order to do that, I'm going to do e to the power of both sides because that's what cancels out the natural log over here. And so I'm going to do e to the power of negative 1 on the right side, which is my answer, although I tend not to like to leave it as e to the negative 1, so I might instead write it as 1 over e.